Hey, do you like pineapple? Sweet, refreshing, and such a mood booster, right? But wait, don't throw those pills away just yet. Turns out, pineapple pills can become biobatteries. Pineapple pills contain compounds that can produce ions for eco-friendly electricity. You can actually use them in biobatteries. Have you ever thought about this? Pineapple pills, which we usually just throw away, can actually be turned into a source of electricity. Indonesia still relies heavily on oil and coal, and those resources are running out. One alternative is the biobattery, a battery made from organic materials. And what we're currently researching is biobatteries made from pineapple peel waste. Pineapple peels actually contain acids and electrolytes that can generate electricity. But to make it work even better, we also add table salt as an iron source and tapioca flour as a matrix to keep the biobattery stable and long-lasting. The goal? To make a biobattery that produces strong enough voltage and current while being environmentally friendly. This research isn't just about energy, it's about how we can turn waste into something useful and impactful. So from now on, don't throw away pineapple peels, they might just power our future. Curious to learn more about how pineapple peels can become biobatteries? Let's find out in this video.
Okay, for experimental product, wash the pineapple peel thoroughly, then cut into the small pieces and blend the pineapple peel pieces with 10 ml of distilled water and for 2 minutes. After blending, we measure the pH level of the pineapple peel using pH meter. Next, put the extra pineapple peel into separate beakers with the varying mass is 14 grams, 16 grams, 18 grams, and 20 grams. For make a solid electrolyte paste, weigh 20 grams of tapioca flour. And we add 20 grams of tapioca flour to pineapple peels variation in beaker glass. Then, mix it into each pineapple peel's extra variation for using a glass stirring route from a solid electrolyte paste. And for measurement of current and voltage, we prepare aluminum foil sheet for the solid electrolyte and we put the pineapple peels variation on the aluminum foil. We connect the setup to digital multimeter for using alligator clips to measure currents and voltage for determine the optimum point. After we identify the optimum pineapple peel mass, now we optimization again pineapple peels with the NSL addition. First, we add NSL to the extract in the varying amounts is 2.5 grams, 3 grams, 3.5 grams, and 4 grams. After we preparation the NSL with the varying amounts, we put the pineapple peels in varying mass is
14 grams, 16 grams, 18 grams,
and 20 grams, and we mix them all. Then we mix 20 grams of tapioca flour into the beaker glass to each NaCl variation solution to form a new solid electrolyte. We mix them using a glass stirring rod. And for remeasurement of electrical properties, place the modified electrical base, pineapple peel, plus NaCl on the aluminum foil. We measure the current and voltage again to determine the new optimum point. And to analyze change in the battery performance, we measure the resistance of the solid electrolyte using an ohmmeter to determine its conductivity.
This discussion will explain how variation in the mass of pineapple juice and table salt NaCl performance characteristics of the biobattery bus of chalk current voltage and this resistance state of the solid electrolyte state.
Our research for the fusion and vary the mass of pineapple juice, which was mixed with tapioca flour to form a solid electrolyte. The goals of the scientist is to determine the optimum mass pineapple juice that yields the highest current and voltage. The data with about showing the following: when the mass of pineapple juice was 12 grams, the current was only 0.25 milliamperes and the volt was 0.389 volts. However, when the mass was increased to 8 grams, the current rose to 0.83 milliamperes and the voltage reached 0.532 volts. After that, at 20 grams, the current actually descended to 0.48 milliamperes and the voltage dropped to 0.6 volts. What can I call their word? Ensure in the bio battery performance as the amount of pineapple juice inscribed up to optimum point at 18 grams. But the points, the current and volt duration possible due to exchange weather content or ions in the solid system with its correct resistor. Now look at that is the resistor data. That resistor at 20 grams were from 0.80 kilo ohms that determined to 5.60 kilo amperes at 8-9 grams. When show this seems like straight to resistor volts are code and to lower resistance was actually observed at 8 grams. What doesn't mean? When the amounts of pineapple juice is balanced, the ions it's like potassium, magnesium, and sodium can move on really beautiful tapioca particles. This is exact conductivity and to optimize growth output. But when it's too much juice, is the become too easily paid result for in the interaction beauty in ions down their movement which addition concentration again of determinant of optimum mass of pineapple juice with a content the reset by ending table salt and NaCl. It ensures to mixture to five of how much it contributes to improved battery performance. The relation show its similar partner At 2 grams of NaCl, the current was on 0.68 milliamperes and voltage was 0.0 volts. And at the 0.5 grams of NaCl, the current in relation to 3.9 on milliamperes and the voltage raised her 0.775 volts. However, when the NaCl mass was increased to 4 grams, however, when the NaCl mass was increased to 4 grams, the current differed to 3.773 milliamperes and voltage differed to 0.640 volts. What choice is employed? NaCl carries the number of the free Na plus and Cl minus ions, the solid electrolyte. The more ion variable, the higher the constituency, which means high current to voltage. But when your concentration exceeds the threshold, that is more than 3.5 grams, ions becomes too closely packed. This may lead to performance of ion phase with our natural and don't contribute to excellently, or it may cause revolution intolerance between ions as relation condition determinants resistor interest and the battery powers weakens. The resistor data support after that it rose again to 2.8.
Based on the experimental procedure and data obtained, the study successfully developed a biobattery using pineapple peel extract as a natural electrolyte, sodium chloride as an ion source, and tapioca flour as a stabilizing metric. Key findings include is the further optimization with 3.5 grams of sodium chloride significantly changed performance, yield 3.91 milliamperes current and 0.775 volt, with the loss resistance 4.20 ohm. The second is connectivity mechanism. Increasing pineapple peel must innately improve connectivity by reducing electrolyte resistance from 4.80 to 5.60 ohm. Third is environmental impact. The biobattery demonstrates eco-friendly energy conversion by utilizing agricultural waste, aligning with sustainable development goals.